Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So this question, they're asking for a lot: the capacitance, the charge, the electric field, the potential energy, and the potential energy after we're including a dielectric. So let's just write down our givens. We have an area of 2.0 meters squared, and then we have a separation distance of 3.0 millimeters. We can say this is equal to 0.003 meters. And we have V sub O equaling 35 volts. So the first thing, we should find the capacitance. The capacitance, C sub O, is going to be equal to epsilon naught, the electric permittivity of free space, times the area divided by the separation. So this would be equal to 8.85 times 10 to the negative 12th, and then times 2 divided by the separation distance of 0.003. So this is going to give us 5.9 times 10 to the negative 9th farads. So this would be one answer for part A. We could probably do Q sub 0, so the charge. Q sub 0 is simply going to be equal to C sub 0 divided by V times V sub 0. So this would be 5.9 times 10 to the negative 9th, and then times 35 volts. So this is going to give us 2.1 times 10 to the negative 7th coulombs. So this would be our second answer for part A. We need E sub 0. So this would simply be equal to V sub 0 over the separation distance. So this would be 35 volts divided by 0.003. And we're getting 1.17 times 10 to the 4th volts per meter. So this would be our third answer for part A. And then our final answer for part A would be the potential energy. So this would be equal to 1/2 C sub O times V sub O squared. This would be 1/2, and then this would be 5.9 times 10 to the negative 9th. And then this would be 35 squared. So we have a potential energy of 3.61 times 10 to the negative 6th joules. So this would be our final answer for part A. Now, for part B, they're asking us to include the dielectric. So include dielectric. And the dielectric constant, K, is going to be equal to 3.2. So we can say that the new capacitance is equal to the dielectric constant times the C naught. So this would be 3.2 times 5.9 times 10 to the negative 9th. And we're getting, this is equal to 1.89 times 10 to the negative 8th farads. And we know that the voltage doesn't change. So essentially, voltage, Q, the charge, is going to be equal to CV. At this point, we found both of these, so we can have 1.89 times 10 to the negative 8th, and then the voltage doesn't change again. So this is only 35 volts once again, and this is going to equal 6.61 times 10 to the negative 7th coulombs. So this would be one answer for B. This would be your second answer for B. Again, the battery is still connected. The voltage is constant. So the electric field, E, does not change. The separation distance doesn't change, as well as the voltage. So the electric field doesn't change. So E equals E naught equals 1.17 times 10 to the 4th volts per meter. Again, this would be your third answer for part B. And then your final answer for part B would simply be equal to half, and then this would be CV squared. So it'd be 1/2, and then 1.89 times 10 to the negative 8th. This would be 35 squared. So our final answer for part B, the potential energy, would be 1.2 times 10 to the fifth, rather 10 to the negative fifth joules. This would be our final answer for part B. That is the end of the solution. Thank you for watching.